Hi all, today we are going to discuss about the corona phenomena. So the literal meaning of the corona is a ring of light that appears around the sun. So this phenomena we are using to describe the partial discharge that develop in the presence of high dielectric field on the surface of the conductor. Let us take for example, if you take a power system, so power system will have literally minimum 2 conductors and sometimes even more than 2 conductors. Let us take the example, one conductor is carrying a positive value of the charge and the second conductor is carrying a negative value of the charge. So let us assume radius of each conductor is equal to small r, and let us take the distance of separation between them is capital D. So if you want to find the electric field at the surface of the conductor, because if you want to plot for the electric field intensity, we have seen in electromagnetic field theory that the electric field inside a conductor will be 0 because it is an equipotential surface, and the electric field will be maximum at the surface of the conductor and it will go on decaying as you are moving away from the conductor. So we can define the electric field intensity as that value of lambda divided by 2 pi epsilon naught into r. So this is the value because of the first conductor. So because of the first conductor, the electric field intensity will be directed like this. Now because of the second conductor at this point, if you want to calculate electric field intensity because of second one also in the same direction. So we can tell the total electric field intensity on the surface of any conductor will be due to first one plus due to second one also, because it is in same direction, minus into minus becomes plus. So this will become 2 pi epsilon naught into d minus r. So this is what we get. So this much extra electric field intensity is stressed on the surface of the conductor. Because of this electric field intensity, what happens? Theoretically we assume that the air is a pure insulator because in between the medium is air. So before proceeding, I want to tell you, I am providing the complete handwritten material in the description below. You can download the handwritten material for the exams from there. So here you try to understand the concepts. Because I am writing on a glass screen, here handwriting will not come properly. That's why I am only explaining the concepts here. Remaining material or any other things you can download from there. Whatever the important points are there, only those things I am going to write here. So now, practically speaking, the air will not be a perfect insulator because due to the multiple parameters such as ultraviolet radiations from sun, cosmic rays and radioactivity of soil. Because of the radioactivity of the soil and cosmic rays as well as ultraviolet rays, always some charged particles will be available always in the air. Now because of this, what happens? You are applying the electric field. Whenever you apply the electric field, the charged particles, let us assume the negative particle also may be there as well as the positive particle may be there. The positive charges will be attracted by this negative one and the negative charges will be attracted by this positive conductor. So always there will be some current. That current we can call as the used to convection. So due to convection process, so the current will always pass between these conductors because convection current is one which is not associated with the conductors which is happening in the free space. So the convection current will always happen, but generally the value of this convection current is very less. So generally this convection current can be neglected. This is what happens practically. But now if you are increasing the voltage such that the electric field intensity at the surface of this conductor, whatever E is calculated at the surface of the conductor, because it depends on the radius of the conductor and distance of separation between them, if the charge, amount of charge that is passing inside, and if the value of the voltage is increased to certain extent that the electric field intensity at the surface of the conductor is greater than 30 kV per centimeter peak, because this is the value peak, or 21.2 kV RMS value, the air will start breaking down. The meaning of air starting breaking down means the particles of the air get attracted towards this, and due to the particles which are already available, which the current is passing due to convention, they acquire the sufficient energy, they will start accelerating at a faster rate. So when those charges accelerate at a faster rate, so what they do, they will start bombarding with the neighboring atoms. So let me try to explain in another page. So let us assume I am taking a conductor. So at the surface of the conductor, let us assume it has reached 30 kV per centimeter. When it has reached 30 kV per centimeter, so here air get ionized. That means whatever the particles that are lying here, they will start accelerating at a faster rate. Due to the acceleration, they will collide. Like let us take for example, one electron is there, it will go and collide with an atom. Whenever it collides with an atom, so it releases a negative charge as well as the remaining will become the positive ion. So this positive ion will be attracted towards the negative conductor, and this negative charge will be attracted towards this. So in this process of this, again it will collide with another atom. So this is a cumulative action, and because of that, a small circle or the small area around the conductor will start conducting, because whatever the electrons are produced, that will come and accumulate on the surface of the conductor. So let us assume that it is always positive. I am not taking the case of AC. First I am discussing for the case of DC, then we will go for the AC. So now when you are applying only 30 kV per centimeter, that will be only at the surface of the conductor, because we know that the electric field intensity will as you go, because up to the surface of the conductor, up to here the electric field intensity is 0, after that it will go on decaying. So just if you are crossing this point, that value is less than 30 kV per centimeter. As this value is less than 30 kV per centimeter, it is not going to have any effect. So only a small area around the surface of the conductor will get affected. So now what is the solution for this? Let us assume the voltage is further increased to such a range that 30 kV per centimeter is coming at some distance far away from this surface of the conductor. Let us assume it is happening at this point. So at this point it is 30 kV per centimeter. Now what happens? Whatever the area is there between these two, that means between the surface of the conductor and the point where 30 kV per centimeter is coming, that will get ionized, because as that got ionized, it will also start acting as a conductor. As the particles came and accumulate on the surface of the conductor, they will start acting as a conductor. They will contribute for your conduction process. As they are moving, so they will be visible in the form of a light. They will be visible in the form of a light. So it depends on what is the polarity. Like for example, if you are taking the positive conductor, here electrons will form. So here the current direction, that whatever the color that comes will be different. Similarly, if you are taking a negative conductor, here negative conductor, only the ions will be formed at the surface of the conductor. And we know that the weight of the ions, because when you remove the charge from any type of particle or any type of atom, so it gets positively charged. So from this ion, because ion will have more weight, it will not have so sufficient mobility as compared to that of the electrons. So that's why as the mobility is less, the color that will be visible for the case of negative conductor will be different. So practically if you are applying the DC current, the current that appears here will be bluish white color will come on the positive conductor, and here the mobility of these carriers are very less. So it will not form like a uniform circular ring, it will form like a tufts. So it will be in the color of reddish tufts and beads are formed. So along with that, it produces some gas also. That gas is called as the ozone gas. This gas is ozone gas. That ozone gas can be detected by the smell of the particle. The disadvantage of this ozone gas is whatever the ozone gas is produced, that will corrode your conductor. That means because of the ozone gas, your conductor will get corroded on the surface. And it is also observed that how much amount of this the breakdown happens, that depends on the shape of the conductor also. If the shape of the conductor is circular, it is less, but if the shape of the conductor is random, because this can happen in the case of ACSR conductors, or sometimes the dust and dirt is formed, it is observed that the potential gradient will be maximum at this point, pinpoint, and this will get affected due to the corona first when compared to the remaining part of the conductor, or we can tell the corona happens at less than 30 kV per centimeter. And not only that, this corona also depends on the atmospheric conditions, because whenever your atmospheric condition is a stormy weather or a rainy weather, so in that case the number of carriers will be more already existing in the air. So when the carriers are more for the given electric field, automatically because the carriers are more, so automatically the effect of corona will be more. So now you have to remember that whatever this electric field is there and that is producing some motion in this and responsible for dislodging some more charges. So this energy should be supplied from somewhere. So where this energy is supplied? This energy is supplied from your supply only. That means some energy is spent from your supply. So in order to produce this phenomena, that means we can tell that some energy is lost in the corona phenomena. That energy lost will be dissipated in the form of a light. So it will be dissipated in the form of a light, heat and the characteristic odor. That odor will be that ozone gas will be produced. In these three forms it is dissipating. So thus power will be taken from your supply only. So let us take the case of the AC. So if you are taking for the case of AC, so I am taking a conductor. If you take the conductor, there will be phase and neutral only. So phase conductor, this will be positive for one half cycle and negative for another half cycle. So during the positive half cycle, what happens? It will attract the charges towards it. And during the negative half cycle, this negative charge will be repulsed by it. That means whatever the charged particles are in the air, first they will be to and fro. That means they will move like this and after some time like this. As they are moving in both the directions, so one time they are moving nearby, one time they are going afterwards. So same thing will happen to the second conductor, negative conductor or the neutral conductor. So here also one half cycle it will repulse and another half cycle it will attract. So this process continues as this is same for both the conductors. So that's why the phenomenon or the color will be same in both the conductors. Here the color that will come will be violet color. The violet color will appear. And second one, in the case of AC, because it is a continuously passing, that means it is going away, coming, going away, coming. So because of this the hissing noise also will be visible. So hissing noise will come. This hissing noise is due to attraction and repulsion of the charged particles. And the second effect of this corona is because we know that the conductivity will start only if at the surface of the conductor whatever voltage is there, it is greater than 30 kV per centimeter. This is 30 kV per centimeter. So if you take your AC supply voltage, because AC supply voltage is continuously varying like this, so because of this the electric field also will goes on varying because it depends on the potential. So the electric field will be greater than this 30 kV per centimeter only for some time, again it will decrease, again for some time and decrease. Because of this phenomenon it is practically observed that the third harmonic components will be induced in your supply. Because these currents are not uniform, the current will change at the rate of third harmonic component, because the current fluctuations will be at third harmonic component because of amount of current depends on the current. So because of this third harmonic component there will be interference with the nearby communication lines. That means we can tell that there will be interference with the nearby communication lines. This is the second one we have to take care. So this is the major problem also. So practically it is observed that if your distance of separation between the conductors, if this distance of separation between the conductors, let us assume this is d and the radius of each conductor is r. So if d by r is greater than 15, then only the corona phenomena will happen. Otherwise if d by r is less than 15, the complete breakdown or breakdown of the conductors happens, or breakdown of the medium happens before the corona phenomenon can start. So but practically always the d by r will be greater than 15. And because this corona cannot be visualized by a normal naked eye, if you want to see the corona, there is an instrument that is used. That instrument is called as stroboscope. The instrument that is used for observing this is called as the stroboscope. So in the next class onwards, we are going to see how the corona phenomenon stunts and what is the derivation for this and how much amount of the power loss will happen and all the details. I hope up to here the concept is clear to you. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you very much.